Hello students, good morning. Good morning everybody. So I hope you are enjoying at home, right? Okay. Fine, good morning. So we'll do some questions on as usual on atomic structure, right? Okay. Just give me 1 minute. Fine. So we'll start with atomic structure. Last time students we had done these sums n plus L plus Ml like that sums we have done, right? Now today we will discuss about nodes. Okay. See what is a node? Okay. Node, you know, those points, right, or that region, better will say that region, right, where the probability of finding electron is zero. There you can't find the electron. Electron anga irukal. Where the probability of finding electron, right, yes, is zero. Correct? Okay, students. Now, there are two types of nodes, students. One is called radial node, the one is called angular node. Node means where you can't find the electron. Radial means you're speaking in terms of distance. So suppose like this is the nucleus, right? This distance, right? So this is radial node, distance, right? Angular means you're speaking in terms of planes. Okay. See, angular node is also called a nodal plane. So you're speaking in terms of plane, right? Here you're speaking in terms of points. Okay. Clear? So radial nodes are distance, right? It's nodal planes. Fine. Student, there is a formula for this. You remember that formula, but very important is you should understand that formula also. See, number of radial nodes is equal to, there is a formula, you can by heart it, right? Number of radial nodes is equal to, okay, n minus L minus 1. What is number of radial nodes? N minus L. What is number of angular nodes? Number of angular nodes is equal to L. Okay. And total number of nodes. So if you want to see the total number of nodes, right? What is the total number of nodes? Total number of nodes is equal to, you add up these two students, right? N minus L minus plus L. So you will get the answer as N minus 1. This is the total number of nodes. Okay. So this is the formula. Please remember this is very important. Nodes are those points, where you can't find the electron. Electron agar irukal. Okay. N minus L minus 1. Radial. So students, note down this formula first. Then we'll do sums on this, right? Then we'll see, how are these nodes actually, right? Fine. So please, I'll give you 2 minutes. Just write on your book. Then, when I give questions, you can answer, right? Fine. So I hope you have done this, right? N minus L plus N minus 1, right? Okay. Now, let us take some orbitals now. Let us take some orbitals, right? Let us take 1s orbital. So for 1s orbital, tell me what is N? N is 1, L is 0. S orbital means L is 0. Okay. So what will be the number of radial nodes? Yes, tell me. Very simple formula we had, right? N minus L minus 1. So you just substitute the values. So you will get 0. So that means 1s orbital has no node. Node கிடையாது அதுக்கு. அப்படின்னா என்ன அர்த்தம்? எலக்ட்ரான் எங்கேயும் பார்க்கலாம். 1sக்கு எலக்ட்ரான் எங்கேயும் பார்க்கலாம் நீங்க. No node. So if you take for 2s, same answer. Number of radial nodes will be what telling? 2 minus 0 minus 1. L is 0 for s orbital. So you'll get one node. So for 2s you will get one node, right? So in same way, 3s you will get 2 nodes. But I'm talking, listen here, I'm talking of this concept, I'm talking of radial nodes. Okay. So if you want to draw the picture, the picture will look something like this, This is the nucleus. Fine. This is the 1s orbital. You see 1s orbital, right? Now this is the 2s orbital. You see very carefully what I am drawing. Now in between, you will get a node. Can you see this? Students, this is a node. At this point, there will be a node. So here you can't find the electron. No chance. Probability of finding the electron is 0. No electron. So for 2s, you will get one node. Are you clear? 2s, you will get one node. For 3s, you will get two nodes. Okay, like that will keep increasing. 4s, you can draw that also, right? For 3s, you will get two nodes, right? Okay. So after this, two nodes will come. I can draw it like this, right? Node here, another node here, and then you will get 3s orbital. Are you clear? So it looks something like this, right? So you will get node here, this is also node, this is also node, right? 3s will come after that. Fine. 3s will get two nodes. So like this you can find out, right? Now, so I hope you have drawn this, right? Now if it is s orbital, students, very important, if it is, listen here, s orbital, what is number of angular nodes? Till now we discussed radial nodes, angular nodes will be equal to 0. Because L is equal to 0, right? And what is number of angular nodes? L. So what it means, s orbital does not have angular node. Obviously. S orbital on the angular node. It's a sphere. Remember, it is a sphere. And sphere, if you look from anywhere, whatever angle you look, right, it will be the same. You can find electrons everywhere. Can you see? Whatever angle. So in terms of angle, no node. Clear? It's a sphere. Are you getting it? So s orbital, students, will not have any, angular node actually, right? Okay. Yes. So no angular node for s orbital. Fine. For p orbital, now let us come to p orbital now. Students, for p orbital, you will get angular node. Just see now how. For p orbital, right? Okay. L is equal to 1. What is the value? L is equal to 1. Okay. So number of angular nodes. Okay. Just now I told one formula. What is the number? L, right? So p orbital, you will have one angular node. One angular node. Let's see what is that. Let's see what. Now let's see what. Let us see now. This is px, right? This is the nucleus. Okay. This is your px orbital. Now, students, this plane, which is this plane I am telling, which contains the nucleus. Okay, va? Inga nama electron paaka mudiyadhu. You can't see the electron. No electron here. Clear? Here you can't see the electron. This is called nodal plane. So this will have one nodal plane. Can you see the nodal plane here? One. Which is, with the nucleus, right? Which is there. Nucleus is there in that plane. So px, you will see one nodal plane. The same thing will happen for py also. So I can draw py. Okay, this is your py orbital, right? Now, student, this is an angular node. See. You see this plane, if you see this plane, right? No electron is there in this plane. That plane should contain the nucleus. So here also one angular node is there, right? Okay. This is also a nodal plane for py orbital. The same thing, student, you will get for pz orbital also. Fine. So you will get, listen here, you will get one angular node. You see this one, this one. For px orbital, what we can say, angular node is a yz plane. What is the plane here? YZ plane. And for py, you can say xz plane. Correct? Py it is xz. Fine, student. And for pz, what plane will you say? XY plane. Okay? Please note down this. Okay. Okay, student, start. For pz, you will get xy plane. Okay? So you will get one plane for this p orbital, right? Fine. Now let us come to d orbital. See, if you see the d orbital, just see very carefully now. If you see the d orbital, right? Okay. D orbital will look some, there are 5 d orbitals. Before that, there are 5 of them, right? Now, what are the 5? Let me draw all the 5 now. This orbital is called dx square minus y square. Yes. This is your y axis, right? This is your x axis. Fine. So, what is this called dx square minus y square? What is the peculiarity of this? The lobes, 4 lobes are there, right? It's double dumbbell. They're along the x axis, correct? And along the y axis. So dx square minus y square. Okay. I will draw all the orbitals, then I'll show you the nodal node and all that, right? So this is called dxy. Okay. Similarly, you can have dxz. Similarly, you can have dyz. Okay. I'm not going to draw that. And you can have one more orbital, dz square. Dz square, right? So this is your, suppose you take this as a z axis. Okay. So this is your dz square. Fine. So you have got 5 now. This also you take it, like. Now what about dxy orbital? If you see the lobes, listen here, dxy orbital, the lobes are in between x and y axis. Can you see? In between x and y axis, right? Similarly for dxz, it will be in between x and z axis. You can draw that. It will be in between y and z axis, right? For dyz. Okay, fine. Now let's see now. Nodes. Now what is the formula? Number of angular nodes, right? Okay. Now the formula is number of angular nodes is equal to L. So what is the L value? L value for d orbital? D orbital, right? L is equal to 2. Correct? So you should get 2 angular nodes actually, right? Fine. 2 angular nodes or nodal planes. Now let us start with this. Let us start first with dx square minus y square. Just see now. If you see this plane, students, if you see this plane, exactly in between the axis, this plane and this plane. Okay, this plane and this plane. Can you see that? Both the planes, right? Now here you can't find the electron. Finding the chance of finding the electron is 0. This plane and this plane. 2 planes are there. That's why you're getting 2 angular nodes. Can you see that? So here you will get 2 nodal planes. Okay, you will get 2. This one and this one, right? Nucleus is there in that. Here also you will get 2. Here you will get 2 like this. Just see, this is one nodal plane along the axis. Along the axis. This is another nodal plane. So this is a nodal plane, right? This is also a nodal plane, right? So 2 you will get, right? Clear? Let me repeat now. For dx square minus y square, you will get a nodal plane, right? Between the xy axis. Between the x axis and y axis, you will get one here, right? So you will get 2. Okay? For dxy, you will get along the axis. The plane is along the axis, right? This axis, x axis, and y axis. Are you getting it? So the same thing, the same thing you can say for dxz and dyz also. Fine. Now, students, very interesting. Surprisingly, dz square doesn't have any nodal plane. No nodal plane here. Why? I'll tell you. Because suppose you take this as x and this as y, like clear. This is y axis, fine. This is z axis. Now for dz square, students, very interesting. These two lobes are along the z axis, z axis, dz square. But if you see a circle, can you see the dot dot dot? Now what does the dot 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 tell you? That means the electrons, remember, are surrounding the two lobes. Okay, lobes are there and you have got electrons surrounding the two lobes also. அந்த லோப் இருக்கு, அந்த லோபை சுத்தியும் electron இருக்கு. You are seeing electrons everywhere. Can you see? Surrounding the lobes. So this orbital does not have any no nodal plane. Everywhere you can see electrons. Are you clear? Everywhere you can see electrons, right? Z axisலயும் இருக்கு, சுத்தியும் இருக்கு. So nodal plane வரவே வராது இது. So this formula will not work here. Please, very, very important. They ask this question in the competitive exams, right? Dz square, no nodal plane. This formula will not work. Please to note down, this is very, very important. Okay. Can you please note down this fast? So I'll show you this dot dot dot. Are you clear? Okay, students. So that's how you will show for dz square orbital, right? So there is no nodal plane. Okay? Fine. So that's all about these nodal planes and all that, like you can remember the formula. Number of radial nodes, right? You can go for f orbital also. F orbital L value will be 3. So L value is number of angular nodes, right? Please remember this formula, okay? So for D we got L is equal to 2. Fine. Okay, L is equal to 2, so 2 angular nodes. Okay, fine. Fine, so that's all about nodes, right? Now we'll go to the next topic here. How will you calculate magnetic moment? So in atomic structure, this part, they ask a lot actually, right? Okay. So I might have explained to you, like what is magnetic moment and all these things, right? In the usual class, NCRT class. Fine. Now in this class, we'll see how to calculate it. There's a formula for this. Magnetic moment is equal to mu is the symbol, root of n into n plus 2. The units are Bohr magnetons. What is it? Mu is equal to root of This is also called BM, where N student stands for number of unpaired electrons. So it depends on, like, so N will give you the number of, unpaired electrons, right? So if you've got, very important now, if you've got unpaired electrons, N is the number of, you will have magnetic moment, mu. Fine. By the way, what is magnetic moment? In Tamil we call Gandham, iron, right, is a magnet, right? So to be a magnet, very important, you should have unpaired electrons. That sir might have explained you, right, why you require unpaired. Okay, you might have done it. But more the number of unpaired electrons, listen here, more is the mu. So this is a formula you remember, right? Okay. Now let us do some questions on this. Let's take a very good example. Let's take iron. Iron, you all know that it's a good magnet, it's a good Gandham. Fine. So what is the atomic number of iron? 26. Fine, 26. So students, you're expected to write the configuration also. Manganese, scandium, titanium, vanadium, manganese, chromium, iron. But do you remember the atomic number also? Very important, 26, right? So write the electronic configuration now. 1s2, remember the atomic number. 2s2, 2p6, 3s2, 3p6, 4s2, 3d6. Just check, is it correct? 26 electrons, are they there? Just check it up. 10, 10, 26, right? So you have got 26 electrons, just check it up. Okay. Now students, these all will be paired. Up to this you need not check. These all will be paired only, right? Let us come to 3d6. 3d6 diagram you draw. There are 5 d orbitals, right? 3d6, 1, 2, 3, 4, 5. 5. Now 3d6, so you put one electron here. Okay, so this will be 3d6, just check it up. So here this has got 4 unpaired electrons. Can you see? Yes. You have got 4 unpaired electrons. Okay. Now, so n is equal to 4. You require the number of unpaired electrons, right? So you put 4. Fine. So if you put 4, what is the answer you will get? So the magnetic moment will be equal to, this is mu, right? Magnetic moment. 4, 4. So you write here root of, so students, approximately this answer will be 5. Bohr magneton. Bohr magneton is the unit of this. So you'll get approximately 5 Bohr magneton. Okay. So students, for any atom you can do it. No problem. You just require the number of, unpaired electrons, right? How many unpaired are there? You just draw the box diagram, right? You will get the number of unpaired electrons. Okay. So once you know the value of n, you can calculate. More the number of unpaired electrons, more magnet, right? So iron has got a very high value, right? It's got 5 Bohr magneton, right? So I hope you are getting this. Let me give you some other elements now. Suppose the same question I am asking for cobalt. Cobalt atomic number is 27. Okay. So students, this will be same only. You need not even write this actually, right? 3s2, 3p6, 4s2. Then students, you write 3d7. Remember 27 means 3d7. Fine. Draw the box diagram. 1, 2, 3. We are doing according to Hund's rule, remember. 5, 6, 7. Okay. So what is the number of unpaired electrons? Tell me. 3. So what is the formula? Mu is equal to root of 3 5s are 15, right? So you will get approximately 4. Okay. 15. So you will get 4 Bohr magneton, right? Okay. So cobalt is 27, right? So very simple, student. You just have to calculate the number of and just get the answer, right? Okay. Can you please add on this? So you'll get 4. Very clear? The real problem, students, will come for chromium. So chromium is a little bit problematic. Let's see what is the problem. Chromium atomic number is 24. So same thing, 1s2, 2s2, 2p6, right? 3s2, 3p6. Here comes the problem. Student, should you write 4s2, 3d4 or should you write 4s1, 3d5? Which is correct? 4s2, 3d4 or please remember this is correct. We have done this earlier. This is correct. Because half filled orbital, right? 3d5. 3d5 means half filled you will get. And half full orbitals are more stable. So what you are doing, you are taking one electron from 4s and putting it into D. Okay, just to make it half filled. Stability will come. So please remember, this is not the correct configuration. Please remember this very important. So chromium will have a problem. So now if you draw the diagram, let's draw the diagram now. So 4s1 means you draw the 4s orbital, right? So one electron, then 3d5. So 3d5, 1, 2, 3, 4. 3d5, 1, 2, okay, 3d5. Fine. Now total, tell me, 4s1, 3d5, total how many unpaired electrons are there? Unpaired. 6 are there. So you'll get 6 unpaired electrons, huge number, right? So chromium, will be a very strong magnet, even stronger than iron. Okay, you might have thought that, iron is the best gandham, right? But chromium is even better, you see, beautiful, 6 unpaired electrons are there. Okay. So what will be the magnetic moment? Mu is equal to, this is a symbol for magnetic moment, right? Magnetic moment, n into n plus 2. So instead of n, you put 6. 6 into 6 plus 2. How much is that? 6 into 8, right? 48. 48 means approximately you will get 7. Bohr magneton. Bm, right? Clear? So you will get approximately 7 Bohr magneton. Beautiful. 48, 49. No. So chromium, please concentrate. That formula, that electronic configuration you have to change actually, right? Okay. So students, why don't you copy this fast? It's very important. So I special attention for chromium, right? Okay, students, have you copied this down? Fine. The same problem will come for copper also. See, copper actually is 29. Okay. So 29 means how do you write 1s2, 2s2, 2p6, 4s2, 3d9. Now see here. Now one more thing, student, you can even write this as argon. You can do that also, no problem. If you're finding it, difficult to write this whole thing, you can write argon. Because argon will have 18, right? 18 electrons. Now, student, now very, very important. Now listen here. This is what we expect, but the correct answer is it should be 4s1, 3d10. It will not be 4s2, 3d9. 4s1, 3d. Why? Because again, same logic. Completely filled orbitals are more stable. Now remember, this is completely filled. 3d10, right? D can accommodate 10. So what you are doing? You are shifting one electron from s orbital to d orbital, right? 4s1, 3d10. Fine. So you are shifting that. Now, only one unpaired electron will be there in 4s. That's it. You need not draw the 3d10. It will be all paired only. Okay, paired only. I hope you are getting it, right? Fine, everything will be paired up. So there is no need of drawing 3d10. So only one unpaired electron is there. Okay. So what will be the magnetic moment? Root of, remember the formula, root of n into n plus 2. N into n plus 2, right? So what will be the answer? Root 3. So you will get 1 n plus 2, 1.732 Bohr magneton, right? Okay. Fine. Okay, student. So this is how you will get for copper. The copper has got completely filled orbital, right? Okay. Okay, so this is how you will calculate the magnetic moment. Fine. So please remember for copper also there's a problem, right? Okay. Now they can also give you ions. Like they can tell you Fe plus 2 ion. They'll ask you to calculate the magnetic moment. So for iron, it is 26. Atomic number is 26. So students, now I'll write shortcut now. I'll write the shortcut. Argon, can you write? 18. And then 4s2, 3d6. 26 means 4s2, 3d6, right? Okay. Now Fe plus 2. Now this is argon, right? Same thing. Now Fe plus 2 means, you have to remove 2 electrons. 2 electrons you have to remove. Now here students, people do a mistake. What they will do is, they will remove the electrons from the d orbital. Please everybody pay attention here. They will remove from the d orbital. You are not supposed to do. You should not do like that. You should remove from the s orbital. Why? Because distance wise, if you see, 4s is a little bit far away. So while removing, you write like this, 3d6, 3d6, 4s2. So Fe plus 2 means you will remove 2 electrons. So you will remove the s electrons. So what will you write here? 3d6. Very, very important. Plus 2 means you will remove the 4s electrons. Because distance wise, 4s is very far away. So remove the 2 electrons from s orbital. Punja D length edukudadu. While writing, we write like this because energy wise, like clear. Energy wise, but distance wise, 4s you remove, right? Write like this, be clear. So plus 2 means 3d6. 2 electrons you have removed. Okay. Suppose Fe plus 3 means, what will be the answer? Tell me. Argon 3d5. Plus 3 means remove one more electron, right? Students, are you getting this? 3d6. Okay, 3d6, so you can draw the diagram, not a big deal. One, two, three, four, five, right? Okay. So you have got 3d6, right? So how many unpaired electrons are there? 4 unpaired electrons are there, right? Then you can use a formula and get it. Root of, that's not a problem, right? Okay. So the main thing what I want to tell you here is that if you are removing 2 electrons, please remember, remove it from the 4s orbital, not from the d orbital, right? Okay. So 4s2, so you will get 4 unpaired electrons, right? Okay. So that's about iron 26, right? Okay, son? Can you please write it down? Fine. So suppose I give you, listen here, I give you chromium 3 plus. How do you do it? What is chromium? 24. Argon. Now only I told you, you should write like this. 3d5, 4s1. Remember? 3d5, 4s1. Now only we discussed chromium, you will write like this. So chromium 3 plus. 3d5, 4s1. It should not be 3d4, 4s2. I think we discussed half filled and all that, right? 3d5, 4s1. So chromium 3 plus. 3 plus means what? You are removing how many electrons? 3, 3. 3 electron எடுக்கணும் 3 electron எடுக்கணும்னா ஒன்னு S ல இருந்து எடுத்துடணும் இன்னும் ரெண்டு D ல இருந்து எடுக்கணும். So you will remove 3. So what will be the configuration? 3d3. Correct, no? You remove one from S orbital. Correct, one from S orbital, right? And remember another 2 you remove from D orbital. 3 electrons. 1 plus 2, right? 3. So you will get 3d3. 3d3, right? Now you just draw the box diagram. 1, 2. Okay. 3d3 means you draw like this, right? These two will not be there. So how many unpaired electrons now? 3 unpaired electrons. So 3 into 3 plus 2, right? So you'll get the answer as 15, root of 5 3s are 15, like clear? You get 4. Are you getting it? 3d3. Nothing here. 3 electrons here. Fine. 5 orbitals are there. So I hope students you are getting an idea now. Like it's easy only. Okay. You have to remove from, again I repeat, you have to remove from S orbital first. Then you remove from the D orbital. Okay. Suppose the same thing was chromium 4 plus. Then what you could have done? 3d2 you could have done, right? Fine. Okay, students, this is all about, this magnetic moment, right? Fine. So I hope you have understood these things, right? So with that, we'll stop atomic structure, chapter. I think we have done a lot of sums, and if you have doubts, you can ask in the doubt class, right? Please ask questions in the doubt class. Okay, then bye then. We'll meet next time. Okay, students, bye.